So hello everyone, my name is Antonin Cheymol, and I'm happy to present you today our research paper named Studying the Role of Self and External Touch in the Appropriation of Dysmorphic Hands. So one of the big promises held by virtual reality is the possibility to feel present and to interact from a body which might be totally different from its own. Like, for example, a flying robot, or why not a unicorn? In addition to the potential application for entertainment that this body, that we'll call here dysmorphic bodies, can allow, they can also enable to develop novel and more efficient interactions, but also to alter the user perception and behaviors. However, if we want to obtain these results, it is important to induce to the user a sense of owning the dysmorphic body, which is why in this study, we wanted to focus on finding better methodologies to experience a sense of owning a dysmorphic bodies in VR. So the sense of owning an external body, which has often been referred to as the sense of body ownership, has been introduced for the first time by Bodevink and Cohen using a tactile stimulation methodology, which basically consists, as you can see here, in applying simultaneously tactile stimulation to the external body and to the user body, which is not visible from the user himself. This methodology was later replicated to induce a sense of body ownership towards different dysmorphic bodies. You can see some examples here with a robotic body, a synchronous hand, or duplicated hands, for example. However, in all these cases, the methodology that was used has an important limitation, which is the fact that it always requires the presence of an external effector in order to, which is often another human actually, in order to induce the tactile stimulation, making this technique less practical and harder to replicate to a larger scale use outside of laboratory. In the rest of this study, we'll call this tactile stimulation methodology specifically when requiring the presence of an external effector, the external touch stimulation technique. One potential alternative to this external touch stimulation technique might be the self-touch stimulation technique, which basically consists of the same simultaneous visual-tactile stimulation, but with the crucial difference that because of, as the participant is applying the tactile stimulation by himself, it does not require the presence of an external effector. So far, this technique has been tested and shown to induce a sense of body ownership towards anthropomorphic bodies, but it hasn't been tested yet towards dysmorphic bodies. So to sum it up, we have on one side this external touch stimulation technique, which has been proved to be efficient to induce a sense of body ownership towards anthropomorphic bodies. However, due to the requirement of an external touch, of an external effector, this technique also lacks of practicality. On the other side, the self-touch stimulation technique is a more practical technique, however, specifically in a dysmorphic context. Due to the difference of morphology between the virtual and real body, we have to introduce an offset between the virtual and real effector position in order to ensure more coherence between the tactile stimulation applied to the real body and the stimulation applied to the virtual body. However, we cannot, during a self-touch stimulation, this offset will also introduce different sensory mismatches in terms of visual motor, but also visual tactiles towards both the active and the passive hand. And to this stage, we cannot ensure that these sensory mismatches won't have a negative impact on the sense of body ownership induced by a self-touch stimulation. And this is why, in this study, we wanted to answer the following question. Can self-touch be efficient to elicit a sense of body ownership towards dysmorphic bodies in VR? Which is a fundamental question that we need to answer if we want to know if self-touch might be a viable alternative to external touch stimulation technique while showing more practicality and being easier to replicate. So to answer this question, we conducted one user study in which we measured the impact of two different variables on the sense of body ownership. First with the tactile stimulation, comparing the self-touch condition and the external touch condition. Then we are also interested in the impact of the virtual hand appearance, in which we compared an anthropomorphic hand appearance condition and two dysmorphic appearance conditions, including one hand with every fingers except the thumb 1.5 times longer than the actual participant finger's length, the longer finger appearance condition, and one block-shaped hand. So we collected data from 24 right-handed participants in an experiment which lasted about 1 hour and was made of 12 sections, comparing different combinations of variables. You can see here the basic structure of one section. I will explain it more in detail just after, but basically it consists in first applying different stimulation to a virtual embodied hand, and then to measure the sense of body ownership with different measures. So at the beginning of each section, participant left hand was embodied with an appearance, virtual hand of appearance corresponding to the appearance condition. Unfortunately, here you can't see the video, but basically, they went through a visual motor task in which they had to mimic the movement of another visual hand that they could see on a screen in front of them, consisting in basic movement, translation, rotation, hand, fingers moving, etc. Then participants went through a tactile simulation in which they had to place their left hand still on the table, which was then to which was applied then a tactile stimulation through a brush, which was attached to a controller for the tracking, and replicated inside the virtual environment. This brush was held either by the participant or the experimenter, respectively in the self-touch and external touch condition. Also, in dysmorphic conditions, an offset was applied between the real and virtual brush in order, as I explained earlier, to ensure more coherence between the tactile stimulation applied to the real hand and to the stimulation applied to the virtual hand. Then, in order to obtain objective measures on the sense of body ownership, participants went through 2 different tasks which results could have been impacted by the appropriation of different dysmorphic bodies. First, with the safe pointing task, assessing the sense of body location, and then with the pressing task, assessing the impact on the behavior during simple interactions. In this short presentation, I won't have time to explicitly in detail these tasks and their results, but I invite you to check out the paper if you want more information about them. Then at the end of each section, participants answered to a questionnaire made of 15 questions regarding the sense of body ownership, but also of subcomponents that could have impacted the sense of body ownership, namely the agency, the sensation of hand change, and the tactile sensation. So now let's observe the result of this study. So as you know, in this study, we wanted to know if self-touch could be efficient to elicit a sense of body ownership towards dysmorphic bodies in VR. And really interestingly, the result that we observed from both objective and subjective measures indicated that, indeed, self-touch was always as efficient as external touch stimulation technique in the induction of sense of body ownership. So you can see it illustrated here with the result of the questionnaire regarding the sense of body ownership. So in this graph, you can see the result. Each colors represents the result of different appearance conditions, anthropomorphic, longer finger, and block appearance conditions. And for each couple of plots, the left one represents the result of the self-touch, and the right one of the external touch stimulation condition. And what is interesting here is the fact that while there is significant results between each appearance conditions, there is no significant results between each stimulation condition when presented under the same appearance condition, meaning that self-touch was never significantly less efficient than external touch stimulation technique in the induction of a sense of body ownership. An other interesting result that we obtained was this result regarding the tactile sensation, which basically reported the perception of realism during the tactile stimulation. What we could observe was the difference between self-touch and external touch stimulation was significantly higher under the block appearance condition compared to the other appearance condition. And one of the main hypotheses that we have to explain this difference of patterns, mostly between 2 different dysmorphic conditions, so the longer finger and the block appearance condition, is the fact that these 2 different appearance conditions actually induce different nature of haptic retargeting, a movement rescale for the longer finger and the movement redirection for the block appearance condition, which later one could have induced a more negative impact on the tactile sensation and might be important to take into account in future utilization. So to sum it up, In this study, we wanted to know if self-touch was a viable, practical alternative to external touch stimulation technique for the induction of a sense of body ownership towards dysmorphic bodies in VR. In order to answer this question, we conducted one experiment in which we compared the sense of body ownership induced by self-touch and external touch stimulation under 3 appearance conditions, 1 anthropomorphic and 2 dysmorphics. And the main results that came out from this experiment is the fact that self-touch is indeed a viable, practical alternative to external touch stimulation technique for the induction of sense of body ownership towards dysmorphic bodies in VR. So now let's finish with just some interesting research perspectives remaining after this work. First, we thought that it would be interesting in a future study to evaluate a wider range of types and magnitudes of body dysmorphism in order to study their impact, but also, as mentioned earlier, the impact of the movement retargeting that they induce on the tactile sensation, but also on the overall experience. In addition, in this study, we wanted mostly to focus on a theoretical validation of self-touch compared to external touch. And however, in the algorithm that we provided, the tactile stimulation was restricted to only 1 specific area of contact and specific tactile to 1 point of contact at a time and specific areas of contact. In future study, we consider that it would be important to provide to provide a more flexible algorithm that would enable an unconstrained self-touch stimulation. So that's the end of my presentation. Thank you very much for your attention, and I stay available to answer any of your questions. Thank you.
Thank you very much. Are there any questions? All right, there's a couple. I think the lady up in this front row was first.
Hi, thank you for the talk. It was quite interesting. Sorry, my name is Sasha and I'm from Bournemouth University studying phantom touch, and also I kind of find your ideas quite curious with regards to body ownership. So my question is, with the method and the study that you did, do you think your results or your method can actually relate to the dysmorphic bodies that are actually used? So for example, if we look at like the metaverses that exist now, if let's say the avatar is, I don't know, a cat with paws, or if there are claws or something that doesn't actually relate anything close to a hand like in your study, do you think that your methodology will still be relevant or would work? Yeah.
Thank you very much for your question. So I guess this is to be honest, this is the first step to answer your question and to answer the need that you evoked. I guess that, as I mentioned, there's to reach this objective, there is still some limitation that needs to be answered. First, requiring a reflexible. If we want, to be in the metaverse to interact freely with our body, with a dysmorphic body that we might have, it might be important to have a reflexible algorithm that will allow any type of tactile stimulation, which so far hasn't been provided by the algorithm, by our algorithm, as we wanted to really have a restrict protocol in which there was exactly a specific stimulation, but it might be important to study different type of stimulation. And again, as we said, it's hard to. There's virtually a unlimited type of body dysmorphism, so we could see that there was already some differences between 2 different types. It might be, as I said already earlier, it might be important to study a wider range and to see each one how different impact they have, because each dysmorphism are of different nature and cannot be considered just as one single thing. Is more than just dysmorphism.
I see. Thank you very much.
Thank you very much.
All right, we have time for one more question.
Hello. Mark Satkowski, Interactive Media Lab Dresden. Thank you for the nice talk. I have a question regarding your procedure. You described that participants had to, in the start, mimic the motion of a VR hand. And how is it done for the block? So how yeah, how could you mimic the movement of different fingers? And then how did this, that they obviously shouldn't be the same for normal fingers and the block, influence your findings that, for example, the self-touch wasn't as good for the block as compared to the other options?
Sorry, can you repeat the second part of the question?
How does this difference in mimicking the motion influence your results in the end?
Or the motion?
Yeah, this mimicking in the first part of your study.
Oh, so yeah, so the motion, actually the reason that, so thank you very much for your question. So in this study, the motion, we wanted to include the motion because as I tried to present it in the start of the presentation, we wanted to try to reflect on what could be actually used during a real utilization to wider range utilization. And in most of VR, what we saw that was that in most of VR applications, we want to have this visual motor provided, the movement provided. And that's why we wanted to provide in all these cases a visual motor beforehand, before the tactile stimulation, a visual motor stimulation and experiencing actually controlling the body. And I guess you also asked for the block appearance condition. So in the block appearance condition, so as you notice, there is no fingers to the block. So we replaced the movement of the fingers by the movement of a waving movement, because we saw that it needed to be replaced, but it could be replaced by the exact same movement. So yes, that's how we did it.
All right, I know that there were a couple other questions, but for the sake of time, we're going to move on. I'm sure he will be available afterwards for more questions. So let's thank the presenter one last time.